All right, so picking up in chapter 18, we just discussed freshwater last time. Now we're going to move on to talking about seawater. So 70% of the earth is covered with seawater at an average depth of 3,800 meters. 30% of earth is dry land. And odd fact is that most of the ocean is still unexplored. In fact, it's probably the part of our world that we know the least about because of, even though the average depth is 3,800 meters, there are very deep, deep parts of the ocean that we just don't have the ability to really go there and understand that part of our world. So the ocean is one continuous body of salt water covering Earth's surface. Now we have three principal regions. The regions are the Atlantic Ocean, the Pacific Ocean, and the Indian Ocean. The Pacific Ocean is on our west coast. It is the largest, it has the greatest depth. The Atlantic Ocean is on our east coast, and it's the second largest in size. The Indian Ocean is the smallest surface area, and it is east of Africa, south of India, and west of Australia. Now, there are seas. A sea is a smaller region that's distinguished by special characteristics. So some examples are the Mediterranean Sea, which is over by Italy and south of Spain. The Gulf of Mexico is our sea here. It's obviously we are farther from it here in East Texas, but it's along the Gulf shores. And then you have the Caribbean seas, which are around the Caribbean islands, very close to the Gulf of Mexico. But the Gulf of Mexico feeds into the Atlantic Ocean. That's its closest ocean next to it. If you see here on the map, you have things like the Arctic Sea, the Black Sea, the Weddell Sea, and the Ross Sea, as well as the Bering Sea. So saltwater is salty. It has what we call a salinity, which is a mass of salts dissolved per kilogram of seawater. So if fresh water is 0.05% salt, then the average salinity of salt water is 3.5%, but there are some variations due to areas that might have heavy precipitation, there might be ice melting or freshwater river inflow, but the average is 3.5%. Now the proportions of ions is relatively constant, meaning the amount of sodium and chloride, but the seawater also contains dissolved gases like nitrogen, oxygen, and carbon dioxide, which are important for life, for aquatic life. Now, if you wanted to make a 3.5% solution of salt water, you would take roughly 35 grams of salt, which is quite a bit, dissolve it in about 960 milliliters of water, which is nearly 1 liter of water, and that would give you the same salinity as salt water. So which ion makes up the majority of salt water? Well, chloride is 55%. So the majority of our salt water contains dissolved chloride ions. Then sodium makes up about 31%. And then you have lots of other ions like sulfate, magnesium, calcium, potassium, bicarbonate, and bromine, all of which also make up seawater. But the two predominant ions are chloride and sodium. So there are two different types of movement of seawater that we're going to talk about. Waves, which are produced by disturbances. So we've talked about waves back when we discussed physics. And then currents, which is the movement of water from one place to another. So when we talk about a wave, the water itself isn't physically moving from one place to another. It's simply changing its motion due to a disturbance, whereas a current is an actual movement of water. So waves are moving crests and troughs. It's like kind of like performing the wave as a person. If the whole crowd stands up, you aren't physically moving your spot. You're just standing up and then sitting back down. And that's what happens with waves in the ocean as well. So there are three characteristics: the height of the wave, which we called the amplitude before, the vertical distance from the trough to the crest. You have the wavelength, which is the distance between two crests. And then you have the wave period, which is the amount of time it takes for two crests, or from one crest to pass and then a second crest to come. A swell is something that carries energy but does not transport water, and the individual particle motions are circular. So swells are something that they talk about down in the ocean or down near the shore. White caps are when the top of the swell is toppled by a strong wind, and so it produces that water, that white color in the wave. So if we're looking at it, you can see this kind of convection-like motion, which is the swell, and it only occurs right there below, or right there at the surface. As you go further down, you stop feeling that motion, that circular motion of the swell. Okay, so take a break, come back, and we'll talk about shore effects.